All right, welcome back, guys. In part 2 of today's lecture, I'm going to be talking about creating pointers to pointers. Of course, we can do that. A little more complicated than just kind of creating a regular pointer, but totally feasible. And then command line arguments, which is the main reason I would ever care to create a pointer to a pointer. All right, let me explain a little further. So, we'll start with a little bit of review about pointers. So, if I create just an integer and assign it a value, and then I look over here, I've got value of n at memory location 300C with a 10 in there. Just as a reminder, integers are 4 bytes, so this next address, 0x3010, will be the next address available. And then I can create a pointer to an int. So star pn, and I need to give that an address, so address of n, and that's going to be somewhere else in memory. And I just stuck it down here near the end at ff2e. I've got the address 300C of n stored in this pointer. And again, pointers on a 32-bit machine require 32 bits. So the next address beyond this one would be, let's see, EF012. So FF32. All right, quick review for you guys. And then I can also create a pointer to a pointer to n, and I just need to give that the address of pn right there. So the address of pn is 0xff2e, so that's the value that gets stored here in a variable called ppn. I really don't care where it is, but that happens to be, I just picked a location, 0204. And I've got arrows indicating that this points to that address, and this memory location holds the address of n. All right, now to keep going. If I actually want to access n, and I'm going to talk about accessing n, pn, ppn, and the address of ppn. So, but first, if I want to reassign n to something like n is equal to 3, I can use any of these 3 notations. I can get to it with any of these. So I can just directly say n is equal to 3, and that will change this 10 here to a 3. I can use the dereferencing on my pointer. So remember, this part right here, int followed by the star, means I'm declaring a pointer. Star means it's got an address in there, and I'm following the address to get to this memory location. So it's going to be using this one instead. So I can do star pn equals 3, and star pn. So basically each star means star with the address, follow the link. I get an address. The second star says follow the link, and now I'll be operating with this memory address. All right. So next up, I don't actually want to change the addresses of these, so I thought I'd just print them out for this example. So if I want to print out the address of n, which is this 300C, I've got a number of ways I can do that as well. I can use the address of operator, and that'll get me 300C. Pn actually just directly stores 300C, so if I just go and grab whatever's in that address right there. And the third way is I could take, oh dear, I've got a typo right there. Timeout, let me go fix that. All right, all better. So here I am, I'm printing out the address of n with the address of operator. Pn directly stores that, and now I can dereference ppn, and that'll say, here's ppn, follow this link to go here, and this is what's actually stored there. That's the address of n. Okay, I made that same mistake all the way through, so on the previous slide, I went ahead and fixed that as well right there, added a p. So sorry about that. And then, all right, so next up, if I want to print out the address of pn right here, I've got a number of ways to do that. I can't actually use n. There's nothing that says from n, I don't have any information that goes and connects it to pn. I can't go that way, so not possible. And then from pn, I can just use the address of operator, and that'll give me the ff2e, or pn up here directly stores ff2e. So I can do it that way. And then finally, to get the address of ppn, if I ever want that, I can't do it with n, there's no connection there. I can't do it with pn, there's no backward connection that way. To print that, the only way I get is using the address of ppn operator. And there's really no practical limit to how many levels of indirection we can have. I can do star, ppn, ppn, something like that, as many times as I want. But in reality, you rarely see more than 2. So why would I ever want to do this? Number one reason is, the best example I can think of is to store an array of strings. So if you remember, strings are just arrays of characters, or character arrays. So for a second, consider storing these three words. CS354 is awesome. So what this is going to look like in memory, somewhere out there, I'll declare a variable. In my demo, I call it S1. So S1, I just picked a location. I'm storing it at 2000, and I've got this string, CS354. And remember, they always need that backslash to terminate a string. So this is going to take 1, 2, 3, 4, 5, 6 characters, or it'll be 6 bytes long. So the next available memory address will be OX2006. All right, and then the next word is. I stuck that at 300C, so we need IS and the null character. And then final word, awesome. I think my demo has some exclamation marks on there, but they didn't fit in this little box, so I took them off. Well, we'll see that in a second. AWESOME, and then the terminal character. All right, so I've just got those three strings in memory. Now I can declare, and remember, character strings are, did I put labels on those guys? Nope, hold on, time out. All right, I just went back and made a couple little adjustments here. So I've got my S1, S2, and S3 labeled here for my character strings. I forgot to put them over here. They're in the demo, you'll see that in a second. I've got my character strings somewhere in memory, so this is a 6-byte string starting at 2000. So S1 is going to hold the address of that. So it'll know it's right there. And then I've got S2 pointing to the second string there is, and S3 is a pointer to this string right here. Now, I can declare a pointer to a pointer by using char ***, and I named it PPC, pointer to characters. And then if we take a look at the memory, this is going to be somewhere in memory, and this is just going to have the address of the very first string in that character array once I put it all together. Let me just go to the code where I've actually got all the syntax. I got it working. One sec. All right, so go back to the code page, download pointer to array of strings, and I'm just going to take a look at what I've got right here to start with. Switched focus. There we go. So what I've done here is just declared 3 strings. So this is a character, a pointer to a character array, and I've just assigned that CS354, and this will be 6 bytes long. Another way to do this would have been to actually use an array like this. I need 6 bytes. This would also work just fine. I'm going to leave it like this for right now because I want to emphasize the pointer aspect of this. So, and then I've done the same thing for the other 2 strings. So this was just really to remind me that these are pointers. The next thing I'm going to do is I'm going to create a pointer to an array of characters. So pointer to an array, that's that bracket 3 of characters. And I'm just going to give those 3 pointers, S1, S2, and S3. Now, they're already pointers, so I don't need to dereference them or anything. These already contain those addresses that I want in this array. And then here's what I was talking about. This is the pointer to a character array. And I just gave that PCA. This is already a pointer to pointers. So this works great. And then I can access all of these. I'm just printing out the strings stored in the pointer to a character array, element 0, element 1, and element 2. So let me get out of here, and we'll just real quick compile this. GCC pointer, I need the -o, and then M32, so all of the addresses are at the right spot, with just 32-bit addresses, and all the compiler warnings. Okay, works with no problem. So now I should have, pointer to array of strings. Pointer to array of strings. Now that when I run that code, it's just going to print out those 3 strings that I had. All right. I highly recommend that you guys take a moment, go back, take a look at this code, and make some modifications. Go ahead and change S1 to use the bracket notation. Go ahead and change this to use different notation. This one to use different notation. Just play around with it, and some things will give you errors, some things will work, and try and come up with reasons for yourself why things work the way they do. And one of the hints I'm going to give you is that when I declare an array, this is going to be a constant pointer to this string of text. So I'm not able to change it. But go ahead, print out the addresses, maybe experiment a little bit. See if these are actually stored sequentially in memory or if they're mixed up a little bit. Check out these. Are they stored right next to each other in memory? I'm just going to leave that as an exercise for you guys. All right, the next thing I want to introduce is the reason I just spent all that time talking about pointers to pointers, is the command line arguments. If I want to run a program and actually get stuff from the command line, requires this. So here, I've got a program CMD line args. Go ahead, download that one and follow along. I'll make some recommendations about experiments that I think are kind of fun, and I'll call them valuable learning opportunities. Anyway, I'm just going to open this up. Let's take a look at it. Return focus to the recording screen. Hold on. There we go. Okay. So first thing I'm going to do is I'm including standard io.h and standard lib.h. Then right here in the main, the declaration for the main function, or definition of main function, inside these parentheses are where I put the variables or the parameters that I'm going to be calling when I use these command line arguments. So the first one here is an integer. Argc is the count of how many command line arguments. So this just breaks up whatever string I use as arguments when I call the function, and counts how many different strings there are, or how many different words. And then I've got, this is the pointer to an array, and this is going to be the values of those arguments. So the arguments that are come in will be character arrays, so strings, and this much right here is the fact that it's a string, and then it's going to give me a pointer to those, and it's going to be an array of strings. So as we go through this, first thing, this particular program is expecting exactly 4 arguments, and if you don't put in exactly 4, it's going to give you this error message. So let me just walk through this. If argc, the count, is not exactly equal to 4, then fprintf, so f, this first f stands for file, I'm printing, and this is the format string. When I add this f here, it lets me specify a direction or a location to print to. In this case, I'm not actually printing to a file, but I'm using the same function. Instead, I'm printing to standard error, which is a lot like printing to the console. I haven't redirected it anywhere. And then this is just going to print this error message. So it tells me how to use the function. So this first s is printing out argv0. Okay, and this is always going to be the name of the program that we're running. So it'll just print that out. And then it's going to tell me that that program requires 3 arguments: the name, age, and an alphabetical character, just one character. And then, after it's printed out that error message, it calls exit. And the value here, well here, exit is a lot like return. This and this are almost the same. The difference is that exit is a system call, call to the operating system that says just kill whatever program's running right now with this error code 1. And this will work even if I'm in a function. So if I have a function that's printing something and I have an exit there, it exits immediately. But return will actually just go back to the function that called it. And when I have this in main, this exit code here, 0, indicates that everything worked just fine. Okay, and then should I have exactly the right number of arguments, it's just going to go through and print these out. So let me go ahead and demo this. So quit, I don't think I'm making any changes. All right, now I've got to compile this. So gcc -o command line args, don't overwrite the code. Command line args.c -m32 turn on all the warnings. Okay, it compiles without any error messages, so that looks good. And then /cmd command line args. Okay, if I just call it without any arguments at all, it's going to give me that error message because I didn't put in the right number. It's expecting me to give it 3 things. The first one is automatically there. It's always the name of the program that I just called. So in this case, cmd line args. And in fact, if I call it without this /, I don't think I have any other functions called command line args anywhere, so it should find this one. It does actually take off the /, so it knows exactly what I typed on that line. Okay, next up, let's call it with just 1. And I also still get the error. I need exactly 3 arguments. So my name's Mike, I'm 45 years old, and my favorite letter is M. So let's go with that. Okay, and once that happens, it's going to print out all of the different arguments stored in the argv, or the values. So 1 is going to just be this string, which is the name of the function. Then argument 1 was my name Mike, argument 2 was my age 45, and argument 3 is M. And check this out. This is also a string. It's not going to be converted automatically to an integer. Talk about how to do that in a different lecture. Let me just pull up one more. Where's Vim? Yep, thing. Go ahead and give this a try too. So this pointer to an arg array. So remember, an array declared like this is just a pointer to a character. So I can actually rewrite this as star star argv, and this will work just fine. So I'm gonna write and save. Then hold on, where's my compile line? Yep, that looks like the right one, and then I need to run this. And it works exactly the same. Pointer to a pointer or a pointer to a character array are the same thing. All right, let me wrap this up and then move on. I'm going to create another video to talk about structures that will be available in just a few minutes also. I'll get this edited and posted, and then I'll make the other one. All right, until then, have a great day.